All right, let's look at the unit circle, and we're going to start doing some trigonometry on the unit circle. This circle is created on an x and y axis that is no longer the x and the y axis, it is the cosine and the sine axis. So when we create this, we always start with what is called the initial ray, that is kind of the positive x-axis. So that's the ray that we always start with. Now, as we open the angle on a unit circle, these would be positive angles. And if we open it up the other direction, these would be negative angles. All right, so going counterclockwise is positive, going clockwise will be negative angles. All right, so we kind of went over that right here with the initial ray. All right, so the initial ray is always started that way. The other ray here is going to be called the terminal side, or the terminal ray. All right, so that's just a little breakdown of the vocabulary. So we have the initial side of a triangle, we have the terminal side of a triangle. So initial versus terminal. All right, and then the angle that is created here, we have two different ways of looking at that. We can measure this angle down here. This little symbol stands for what is called theta. It's a Greek letter that usually represents angles. But let's say we call that angle x for now. All right, so we create this triangle. If we drop a vertical line, we would create this triangle. And then we can do our SOHCAHTOA from there based on what we're looking at. So on the unit circle, why it's called the unit circle, it has a radius of 1, all right, because it is 1 unit long. Right, obviously, that could be longer. It could be 2, 3, 4, 5 units long. But just the base, we're going to say this is 1, and if we drop this triangle, we now have this triangle that's created. And we could use sine, cosine, tangent to find the unknown lengths. We would know that this would have a side of 1. We would need to know this angle measure. So there's two ways that these angles are measured in. One is called a radian notation. The other is called a degree notation. Degree notation is what we're more familiar with. In a brief explanation of what is the difference, degree measures the angle, and radian notation is a measure of the arc. Okay, so if we look at these types of measures, if we know what a 90-degree angle is, so if we created this triangle, this would be 90 degrees, it would be right in here. Okay, so you would measure to here, this would go up, this would create a 90 degree. Well, that is a 1/4 of a circle, because the full circle we know is 360 degrees. Okay, so one full circle is 360. If we're a person and we're facing to the right here, and we decide to spin around, but we face the left, we made a 180-degree spin. Okay, we understand that. That's measuring down here in degrees. But if you're talking about how far of a turn did you go, okay, so what we're going to call this full circle, one full rotation is going to be represented by 2 times pi. All right, so this is 2 pi. So if you went and turned the opposite direction, you're now you're going to create that as 1 pi. All right? Because again, the definition of what we're looking at is 2 pi is equal to 360 degrees. So that means that 1 pi is going to equal 180 degrees. So this becomes kind of our ratio of what we're looking at. And the idea of 360 degrees is a 2 pi rotation. That means its radian measure would be the arc, the going around is 2 pi. And on the inside, in degree notation, it would be 360 degrees. Okay, but by just dividing by 2, 360 divided by 2 is 180 degrees. So that kind of creates the whole circle there. All right, so that's just all vocabulary, background information, and not a whole lot that we're going to do at the current moment with that. We're going to advance it forward and look some more at these angles. So here's some other vocabulary with angles. The word coterminal. That just means what creates the same angle. So let's say we had our circle here, our unit circle. Here we'll put some axes on it. So let's say this right here is the x and the y axis, or the sine and the cosine axis. All right, so we have an angle that I made in red here that is, let's say it's 60 degrees. All right, so this arc right in here, measure of this angle is 60 degrees. Well, we could also measure that by going the other direction. And remember, positive angles go counterclockwise, negative angles go the opposite. Well, if I went a negative 300 degree rotation, I would stop at the same spot that a 60 degree rotation went. So what that means is they are coterminal angles. 60 degrees and negative 300 degrees are coterminal. And the same would happen if we went and called it pi over 3 is 60 degrees. Well, that would be the same as going negative 5 pi over 3. Those would be coterminal. So how we get coterminal angles is by adding or subtracting a full rotation. And a full rotation is 360 degrees, or a full rotation is 2 times pi radians. Right, so to convert between the two, radians and degrees, what you're going to do for radian to degree, we're going to multiply by that ratio that we created. The 1 pi is to 180 degrees. Okay, you could do the same thing with 360 over 2 pi, but might as well make it a little easier on yourself. So here's what happens. If we are given this 4 pi over 5 in radians, and we need to convert it to degrees, what you're going to do is you're going to multiply by that ratio, 180 over pi. We want pi out of the problem, so we put pi on the bottom. Because if you know, back to our algebra, multiplying with fractions, if you have the same thing on the top and the bottom, they cancel out. Well, we want to cancel pi out, so pi goes to the bottom. After that, we multiply straight across. 4 times 180 is 720. We divide by 5, so that angle measure is 144 degrees. Okay. If we wanted a coterminal angle, we could subtract 360 degrees to get negative 216. Okay, so a coterminal angle, all right, so if we were going back up there to the top, you could take 144, we could subtract 360 and say negative 216 is a coterminal angle. We could also add 360 degrees and say that our coterminal angle is 604 degrees. So, I'm sorry, 504. So 504. All right. Those would also be coterminal. We could add 360 again. We could subtract 360 again. All of those would be the same angle, just more rotations going in an opposite direction. Now, typically you want an answer between 360 degrees and negative 360 degrees. Okay, so this 504, what we would do is we would just try to, you wouldn't really need since 144 was given, a coterminal angle, you would just subtract 360. All right, typically when we want an answer between negative 360 and positive 360, and really, to be even more specific, you want one between 0 and 360. So the 144 would be sufficient. But again, the idea of those would all be located on the same spot. You would just go around the circle more times. Okay? But again, converting, you're using that ratio and then simplifying the fraction down. Okay? If you're going the opposite direction, so now we're given 50 degrees is our angle that's given. We want to convert it to radians. So now you're going to multiply, but since you're given degrees, you want to cancel degrees out, so you have to put the 180 degrees to the bottom, because the little degree sign that is missing here, this little degree sign needs to cancel out. All right. So we wind up with a fraction of 50 with pi on top divided by 180. So all you're doing is writing that as a fraction, and then we're going to reduce that fraction down. Both 50 and 180 I can divide by a 10. So when I simplify the fraction, it becomes 5 pi over 18. Okay? Now you can convert it into a decimal if you'd like, but preferably you keep it as a fraction. Okay? That way we don't have any rounded off answers and that sort of thing. Again, if we wanted a coterminal angle, as we go through this, what we would do is we would add, so we would take our 5 pi over 18, and we would be adding 2 pi. But we want a denominator of 18, so you double 18, you're really adding 36 pi over 18. So when we do that, you'd add fractions, it becomes 41 pi over 18. And likewise, we could subtract 5 pi, or I'm sorry, we could subtract 36 pi over 18, and that would give us negative 31 pi over 18. Okay, so again, those would both be coterminal angles. That's a negative there. But again, converting is kind of the main focus of this little slide. But again, understand what coterminal means, especially if you're given an angle that's really, really large. You may want to shrink it down into something between 0 and 360 degrees or between 0 and 2 pi, just so that it's more relevant to one trip around that circle. Right, so that's radian to degree and degree to radian. The last thing that we're going to look at, this is a chart that kind of has all of the x and y coordinates all simplified. I've attached a copy of this within the notes of this section. And what this will help is when we have to find an exact value. All right, so like I said on the very first slide, so when we have that unit circle, and we have this angle up here as we go around the circle, and let's say we drop that angle down. Right. If we take that triangle then, and let's say this was 60 degrees, and we have the unit circle, so the hypotenuse is 1, well, we can find this y and this x based on our right triangle trig. Okay? So we've created this fraction from SOHCAHTOA. Say the cosine of 60 in this case, so the cosine of 60 degrees is equal to x over 1. So on our calculator we do cosine of 60, and we wind up with the fact that x equals 0.5, which is 1/2. So over here, when you find 60 degrees and you go over to cosine, notice how it's 1 over 2. So now, if we go back to this triangle and we say, we're not going to put x there now because we know that's 1/2, we can now say 1 squared is equal to 1/2 squared plus y squared. Well, that's 1 squared equals, well, I might as well simplify that. That's 1 equals 1/4 plus y squared. Now we subtract a fourth. 1 minus a fourth is 3/4 equals y squared. And then now when we take the square root of it, you wind up with the square root of 3 over the square root of 4, which simplifies to the square root of 3 over 2. So that is equal to y. So now we can replace this as square root of 3 over 2. So again, go to this chart. Here's 60 degrees because that was my given angle. The sine is always the y coordinate because remember, this is the sine axis, this is the cosine axis. So the x represented cosine, the y represents sine. Well, here's the sine, which the sine would also be opposite over hypotenuse, so it would have been y over 1. The sine is right here at radical 3 over 2, just like we would have found by drawing the triangle. So this chart is to help save some time. You don't have to draw the triangles. The triangles are already there. They're already created with what their values would have been. Okay, so utilize that to find the exact value. Okay, now, some of these over here, tangent. So just a shortcut here on tangent. All right, tangent is really equal to the sine over the cosine. The cotangent is equal to the cosine over the sine. The secant, the SEC, is equal to 1 over the cosine. And the last one, the cosecant, is 1 over the sine value. Okay, so those are all parts of inverse trigonometry. We'll use that here going forward. But for right now, we're just going to look at, can we find the exact value? All right, so the assignment that you'll have, it will be involving finding an exact value of different angle measures, whether you're given radians or you're given degrees. All right, so for an example, let's say we were finding the cosine of 315 degrees. Well, we want to find that exact value. So we go to the chart down to 315 degrees. We find the cosine column. So that exact value is radical 2 over 2. If we were finding, say, the cosecant value of 3 pi over 2. So we find cosecant of 3 pi over 2. So here's 3 pi over 2. It's right here. So then we go over to the cosecant column. And that answer is -1. If you're given a negative angle, so let's say we were finding the tangent of negative 135 degrees. So we need to find what is a coterminal angle of 135. So we would take our negative 135, we have to add 360, because notice, all of these angles right in here are all between 0 and 360. Okay, because 360 is the same as this row right here. Right, but again, we don't have a negative 135. So if we add 360 degrees to it, we should get an answer of 225. So now we have 225 as that measure. So what we're going to do is we're going to replace this with 225. So now we go to our chart, 225 degrees. We go over to tangent. So that answer is equal to a +1. Okay, so this is where this chart is going to save us some time, save us some headaches of having to draw those triangles, and then use those triangles of what SOHCAHTOA is. So like tangent would have been opposite over hypotenuse divided by adjacent over hypotenuse. Now you have to divide fractions, so on and so forth, and you wind up with opposite over adjacent. Okay. Right here we would have had 1 over, we would have had 1 over adjacent over hypotenuse, and then you got to divide fractions, multiply by a reciprocal, and that sort of thing. So by doing this chart and using this chart, what we're doing is we're creating some shortcuts. Okay, so that's what we're looking at now, is can we identify where these angles are, what these angles are, what their values are, and then just kind of use this chart to our ability to find that exact value. One little last side note down here, it says, but it's very small. On this chart, these 3 lines are undefined. All right, and that's just because you would be dividing by 0. Okay, so for example, the tangent of 90 degrees. Okay, well, the tangent of 90 degrees would have been the sine of 90 degrees, which is 1, divided by the cosine at 90 degrees, which is 0. So when you set up a fraction of 1 over 0, that's not possible. So that's where the 3 lines just means undefined. Okay, can't do it. All right, so that's just the kind of the breakdown of this week of what we're going to be looking at: finding exact values, finding radians, finding degrees, and converting between the two of them.